For as long as we've been looking up at the sky, we've been fascinated by that little red dot, Mars. We've dreamed of walking on its rusty surface for generations. But what would it actually take to go from that sci-fi dream to a real scientific mission? Well, that's what we're going to break down. The dream of Mars versus the harsh reality.
Back in 1990, this one sentence, this single idea, completely flipped the script on how to get to Mars. It was this bold, almost Wild West approach to space travel. And suddenly, a human mission didn't just seem possible, it seemed practical.
And really, that's the multi-trillion-dollar question, isn't it? Because getting there is one thing, a massive engineering challenge for sure. But staying alive, on a hostile planet, 250 million miles away from everything you've ever known, that is a whole other ballgame.
So to understand how we might actually pull this off, we have to go back to the 90s. There was this incredibly audacious plan that basically cut through all the noise and complexity and just got right to the point. It was called Mars Direct, and it was cooked up by these two guys, Robert Zubrin and David Baker. They were basically looking at these gigantic, unbelievably expensive government plants and just got fed up. They said, come on, there has to be a smarter, leaner way to do this.
And the sheer beauty of their plan is how simple it is. It's a two-part punch. First, you send the ride home, but with nobody in it. And here's the genius part. This ship literally makes its own rocket fuel on Mars, just by sucking in the Martian air. It's incredible. Then, and only when Mission Control gets the signal that the gas tank is full, do you send the astronauts, so they arrive knowing their ticket home is already waiting for them, fueled up and ready to go.
And this, right here, just shows you the night and day difference. The official NASA plan at the time was so huge and complicated, they nicknamed it the Battlestar Galactica approach. I'm not kidding. It was going to cost a mind-boggling $450 billion. Mars Direct came in and slashed that price by almost 90%, all by following that simple pioneer principle: travel light and live off the land. Okay, so we've got a clever plan. It's elegant, it's cheaper, but a plan is nothing without a reason. So that gets us to the next big question. Why even go? What's the scientific pull that's driving organizations like NASA today?
I mean, really, why spend all this money and take on all this risk? What are the fundamental mysteries about our solar system, and maybe even about life itself, that we can only solve by actually putting human boots on Martian ground?
Well, it boils down to some of the biggest questions we can possibly ask. The number one question is about life. Billions of years ago, Mars and Earth were really similar, so did life start there too? And if it did, where did it go? What happened to turn Mars into the frozen desert it is today? A human geologist on site could find out more in a week than a robotic rover could in its entire lifetime.
And this brings us to NASA's current game plan. You see the Artemis missions and you might think, oh, we're just going back to the moon. But that's not the whole story. The moon is the training ground. It's the dress rehearsal. Every single thing we do there is practice for the much, much harder mission to Mars, which is currently targeted for the 2030s.
So, we've covered the rockets and the science. But it's possible the biggest hurdles aren't external at all. The real make-or-break challenges might be the ones happening inside the astronaut's own head.
Just let that number sink in for a second. 3 years. You're trapped in a space about the size of an RV with the same 3 people. For 3 years. That's a 6 or 7 month flight each way plus a year and a half on the surface. The psychological pressure is just astronomical.
And then there's this. This is something no human has ever experienced. From the moon, you can still see Earth, our big, beautiful blue marble. But on the trip to Mars, it just gets smaller and smaller until it shrinks to a single point of light, no different from any other star. Psychologists call it the Earth out of view phenomenon, and they think the feeling of profound isolation it could cause will be one of the biggest mental hurdles of the entire trip.
The challenges just keep piling up. You've got the crushing boredom. That communication lag is a huge deal. Imagine trying to have an urgent conversation with Mission Control when there's a 22-minute delay, each way. That's a 44-minute round trip for one question and answer. Then you have things like asthenation, which is this deep space fatigue that cosmonauts have reported. And, maybe most importantly, how does a tiny crew handle arguments when you literally cannot walk away from each other for 3 straight years?
Okay, so let's say we do it. We get our astronauts there, and they're still psychologically stable. Now the real challenge begins. Simple, day-to-day survival on another world.
Look, this isn't like the International Space Station where you can get a resupply ship every few months. On Mars, if a critical part breaks,
You can't just have Amazon Prime it to you. You have to be able to make your own air, recycle your own water, grow your own food, and fix or even build anything you need. You basically need a mini industrial revolution in a can.
And this is where a huge debate is raging right now. Can a Mars colony ever really be self-sufficient? I mean, think about it. Even here on Earth, with a breathable atmosphere and tons of resources, no single town is completely independent. So how could we possibly pull that off on a frozen desert planet where almost everything is actively trying to kill you?
And here are two of the biggest unsolved problems of all. First, radiation. Mars doesn't have a global magnetic field to protect it, so it's constantly getting blasted by cosmic rays. The best idea we have right now is to just bury the habitats under a few feet of Martian dirt. And then there's gravity. We know 0G is terrible for the human body. We know 1G is fine. But what does living in 1/3 gravity do to your bones and your heart long term? It is a massive, massive unknown.
So that cool sci-fi vision of glass domes with sweeping views of the Martian landscape, yeah, you can probably forget about that. The reality of survival on Mars is probably going to look a lot more like living underground, either in buried habitats or inside natural lava tubes, just to shield yourself from the constant, deadly radiation.
And that really gets to the heart of it, doesn't it? Getting to Mars is fundamentally an engineering problem, and we are getting incredibly good at solving those. But living there, that is a human problem. It's biological, it's psychological, it's societal. We can design the rockets to get us there, but the real question is, are we ready for what happens next?